Assalamu alaikum. Welcome to this explainer where we're going to embark on a bit of a business journey together. We are going to decode the hidden math behind how a company operates, survives, and ultimately scales up. If you've ever wondered why businesses make those seemingly counterintuitive decisions when they expand, the answer almost always comes down to the underlying geometry of their costs. So today, we're not just staring at boring spreadsheets, we're actually going to visualize the very heartbeat of production. Here is our roadmap for today's session. We'll be hitting 6 key stops. Number 1, defining costs of production. Number 2, graphing total cost curves. 3, decoding per unit costs. 4, the U-shaped secret. 5, the geometry of costs. And finally, number 6, the long-run view. Let's dive right in. All right, starting off with Section 1, defining costs of production, and specifically the hidden expenses. So before we look at any numbers or graphs, we absolutely have to establish what a business cost actually is. Because believe it or not, some of the biggest costs a business incurs are completely invisible to an accountant, yet they totally dictate every decision a savvy business owner makes. To really wrap our heads around this, let's use an example. Imagine you just quit your well-paying job to open up your very own bakery. Your explicit costs are super obvious, right? These are your actual out-of-pocket expenses to buy inputs. It's the cash you're handing over for bags of flour, your shiny new ovens, and your employees' hourly wages. But what about your implicit costs? Well, that refers to the value of the inputs you already own, used in their best alternative way. And the biggest one in this scenario? That sacrificed paycheck from the job you literally just quit so you could start baking. In economics, to find the true minimum cost of producing your bread, you have to count both, the explicit cost of the flour and the implicit cost of your sacrificed salary. Moving on to Section 2, graphing total cost curves, the short-run reality. Let's look at the day-to-day, short-run reality of this new bakery of yours. Now, a quick heads up, in economics, the short run doesn't mean a few weeks or months. It actually means a time period where at least one factor of production is completely fixed in quantity, like the physical size of your bakery kitchen. So, looking at our total short-run obligations, the crucial thing to note is that our total fixed costs, let's say that's your kitchen rent, remain exactly at $60 no matter what. Even if you bake absolutely 0 loaves of bread, you still owe that $60. Meanwhile, your total variable costs, like the flour and your hourly bakers, start at 0 and climb as your output, or Q, goes up from 1 to 6. Your total cost is therefore beautifully simple to figure out. It's just your fixed costs plus your variable costs at any given level of output. So if you're baking 6 units, that's $60 in fixed costs plus $120 in variable costs, giving you a total cost of $180. Now, let's see how this builds when we actually map those exact numbers out visually. The total fixed cost curve is just a flat, horizontal line at $60. It literally never changes. But check out the total variable cost and total cost curves sweeping up above it. This right here brilliantly illustrates the law of diminishing returns. Notice how the total variable cost curve starts off rising kind of slowly, but then past a certain inflection point, it bends and shoots upward at a much faster rate. Why does it do that? Well, think about it. Adding too many bakers into your single fixed-size kitchen eventually just creates chaos. They're bumping into each other, the oven gets crowded, things slow down, and suddenly squeezing out just one extra loaf of bread is going to cost you significantly more in wasted time and materials. All right, let's jump into Section 3, decoding per unit costs, zooming in. That macroscopic view we just looked at is fantastic for figuring out your overall budget. But to run this bakery efficiently, we need to know the cost of every single loaf. We're zooming in. I'm going to introduce a few terms, but the absolute most vital one you need to remember is this: marginal cost. You can really think of marginal cost as the heartbeat of your business. It tells you exactly how much extra it costs to produce just one more item. Technically, it's the change in your total cost driven by a 1-unit change in your output. So every single time you ask yourself, hey, should I bake one more loaf today? Your marginal cost is the exact number that answers that question. By simply taking those total costs from our previous step and dividing them by our output quantity, we unlock this whole matrix of per unit costs. Average fixed cost, which is just your $60 rent divided by output, drops continuously as you bake more bread because you're spreading that same rent over more and more loaves. Average variable cost and average cost are also found through simple division. But direct your attention to our heartbeat on the far right, the marginal cost. We derive this by looking at the jump between each total cost row. For example, going from 1 unit to 2 units, your total cost jumps from $90 to $100. That $10 difference? That is your marginal cost for baking that second unit. Simple as that. Now for Section 4, the U-shaped secret. Reading the matrix. Staring at tables of numbers can only take us so far, right? So let's take those per unit numbers and map them out visually to uncover a truly fascinating mathematical relationship that dictates efficiency. Notice how the average fixed cost curve just plummets downward? That's you efficiently spreading that rent over tons of loaves. But look at the average variable cost and average cost curves. They form these very distinct U shapes. They fall, hit a bottom point, and then rise back up, all thanks to those diminishing returns we talked about earlier. But here is the real secret. Watch our heartbeat, the marginal cost curve. Do you see how it perfectly pierces both the average variable cost and average cost curves at their absolute lowest U-shaped points? Mathematically, as long as the cost of the next loaf is lower than your average, it's going to drag your average down. But the split second that next loaf costs more than the average, it pulls the average right back up. Because of that, they absolutely must intersect at the exact minimum point. It's like gravity. Let's get a bit deeper in Section 5, the geometry of costs, visualizing the slopes. Now, you might be wondering, is that perfect intersection we just saw a total coincidence based on the numbers we made up, or is it a universal rule? How exactly do those sweeping total cost curves translate so perfectly into these U-shaped per unit curves? Well, we can actually solve this elegantly with pure geometry. Look at this brilliant breakdown across these 4 panels. In panels A, B, and C, if we draw a straight line straight from the origin, the 0 point, to literally any spot on our total cost curves, the slope of that line gives us our exact average cost at that output. For instance, in panel C, the slope of that line labeled ON gives us the average cost at exactly 2 units. And as your bakery produces more loaves, that slope gradually flattens out, hits its minimum point, and then gets steeper again, which perfectly creates our U-shape. But panel D is where the real magic happens. It shows how marginal cost is derived directly from the slope of the total cost curve itself at any specific point, rather than drawing a line from the origin. The exact steepness of the curve at any given spot is your marginal cost for baking that specific extra loaf. It is a gorgeous visual representation of calculus in action, and it totally dictates whether a business survives or fails. And finally, Section 6, the long-run view, the ultimate boss level. Up until now, we've been trapped inside a kitchen of a fixed size. We've been fully analyzing the short run, but let's zoom way, way out to the long run. This is a time frame long enough where absolutely nothing is fixed. Your bakery can expand, it can move, you can build massive industrial factories. In the long run, there are 0 fixed costs, which means you can build literally any size plant you want. If you want to bake 1 million loaves a day, you build a massive, highly automated plant. And because you have the power to choose the perfectly sized plant for any level of output, the long-run average cost curve acts as an envelope. It smoothly hugs the absolute bottom of all your possible short-run U-shaped curves. It represents the absolute minimum per unit cost of producing any level of output when you finally have the luxury of sizing your facilities to perfectly match your grandest ambitions. So as we wrap up this explainer, I want to leave you with this one thought to ponder. Whether it's about your own future enterprise or just any business you interact with in your daily life, if you have infinite choices and absolutely 0 fixed costs in the long run, how big will you dare to build? Your ideal scale isn't just about dreaming big. As we've seen today, it's strictly defined by the very real hidden geometry of your costs. Thank you so much for joining me to decode the math of scaling. Keep visualizing the numbers, and I'll see you in the next one.